Hello and welcome to the quick start video on the Network Service Assistant, also known as NSA. We're going to start by a quick physical overview of the product. I've got an NSA unit here in front of me. We can see the touch screen is on. You will notice a flicker in the video. This is just the interaction between the camera and the display. The unit itself does not have a flicker that you would see when you're using it. When you first power up the unit, it's going to be in the multi-gig mode. You'll see the multi-gig button right here is highlighted. To switch to the Certalite test, and we'll talk about all these tests throughout this video, you're just gonna hit on that cable Certalite button right there, and it will automatically switch over to that mode. And you'll see that you're in the test screen. I can just hit my home button right here and go right back to that home screen. That button will take you back to the home screen no matter where you are. If you're into the settings that we're going to be talking about and you want to get back home, just hit that home button. And that's useful if you go into edit maybe a cable type or a test limit while you're in the middle of a test and you want to get back to the home screen. You can just hit that home button. The next button over here with the check mark is an auto test button. So this will automatically run the last test that you ran. So if you've been running Certalite tests and you go in and edit a parameter, maybe a different cable that you're testing, and you want to start running the test again after setting that new parameter, just hit the check button. You don't have to go all the way back to the test screen. The other button on the front here is your power button. This powers the unit on and off. There is an LED here. It's hard to see on camera, but that is green. And that means that I am powered up under battery. If it is yellow, that means I'm powered up, but I'm plugged into the AC charger. If it's red, that's when it's powered down and plugged into the AC charger. On the side here, we have several ports. We've got a AC charging port right here, so that's where you plug in your charging adapter. There is a 1 gigabit Ethernet test port on the side. So this is not for doing physical cable tests. This is for doing a 1 gigabit SNR test. You can also use it to connect to a live network with an internet connection, which you can also do through the multi-gig port on top of the unit. The next port is the USB interface for the USB flash drive. This is what you would use to offload test results. You can also use it to update firmware, and you can use it for importing custom labels. The other thing that this port is used for is with the addition of an Etamax USB Wi-Fi adapter, which looks just like this, just small little adapter. You can also do Wi-Fi testing, so it will enable the onboard Wi-Fi testing functionality. Those adapters are available separately through online vendors like Amazon for about $20. The next port here is the micro USB port. This will allow you to connect with the included USB cable directly to your PC to upload test results directly into the PC through that cable into the Test Data Pro PC software, which is also included. The next port is an internal diagnostic port that we use, so you don't need to worry about that. On the back of the unit, you've got a kickstand, so it allows you to stand the unit on its own. Underneath the kickstand, you'll see a serial number label. The other thing that's on the back is the adapter. So when you're changing adapters, your unit, the NSA will come with the AD-NSA adapter, which gives you the Certalite channel testing port right there, and then it gives you an Ethernet port up to 10 gigabits per second for doing multi-gig SNR testing and network discovery, and ping and trace route, switch detail, all those kind of things you can do through that port. The red and black banana jacks that are on the top are used if you were going to be doing an external PoE load test. That's the other thing you can do through that Ethernet port is do your PoE load testing as well. Inserting and removing adapters is as simple as squeezing the tabs on the side, pull straight back, and you'll see the main connector, and you see the main connector on the adapter. To insert, just repeat the process, line up the notches, squeeze the tabs, and insert into the body of the tester, and it will recognize the adapter once you've inserted it, and it will go into the default mode for that adapter, and in this case that's the multi-gig. So if we wanted to go back to the Certalite, we'd have to hit that Certalite button so we can do our physical cable test. So a couple other quick notes about this. Again, the unit I've got right here is our newer capacitive touch display, so you can go through your settings or go into your tests, change your test modes just with the simple touch of your finger on the display. It is a capacitive touch, much like a cell phone. If you've got one of our legacy units that came out before we went to the capacitive display, that will have a resistive touch display, and for that you would use the included hard stylus that comes with those. It's a small stylus, or you can use a pen like this with the ballpoint retracted. A pen like this also has a soft tip on the back end that I've got here, which I could also use on my capacitive touch display. So that's the main difference between those two units, the capacitive and the resistive. The resistive display would use a hard stylus. Other things to note about this unit, it does come with one remote terminator. So the NSA, it's going to run the normal required tests you'd see on a certifier, but it's doing them from a single-ended perspective, so it's not certification. So you'll be able to do crosstalk and return loss and ACRF and all those things, but it's doing it into a remote terminator like this. And the main unit, the NSA K30E, comes with one of these with remote ID number 1. You can also get an accessory kit that comes in a pouch like you see here, and this will give you multiple remotes. So you get remotes number 2 through 8, plus you get this 200 FP filter probe made by Tempo. This probe will demonstrate with the tone generator function later in the video, and this will allow you to use the tone generation function and trace that tone, but also filter out the AC voltage buzz or noise that you normally see in a tone probe operation. So next, I'm going to go ahead and connect this unit to my PC so I can show you the screen in an easier to see format than on camera, so we can go through the rest of setting projects and running some quick tests. So now I am connected to my computer, displaying the screen of my NSA over here on the left hand side. We can still see the NSA on camera here, although the screen is blank because I have transferred that to my computer. So we're going to use this for our demonstration purposes, and I've got my AD-NSA adapter is already inserted. One note about the remote terminators: these are used only for the Certalite physical cable test. That's the Certalite channel test for the Cat3, Cat5e, Cat6, 6A. That is what the remote terminators are used for. All other tests that we'll do with NSA, whether it be a multi-gig, a PoE test, the base T test through the side Ethernet port, or the network test, those tests will be run directly into a live network. So they would go over a link into a switch, for instance. Fiber tests, which we'll talk about later, would be using a single fiber adapter that has a transmit and receive port, a light source and power meter port on the top, and a loopback at the far end so that you can test that fiber. So just wanted to make sure that it's clearly understood the remote terminator is used specifically for the Certalite test. So we are going to cover the Certalite testing first, and because we're in this multi-gig mode, I'm just going to click on Cable Certalite to switch over to my Certalite mode, and then we will go ahead and go through setting up a physical cable test project or a Certalite project. So the first thing we're going to do is click on this project button in the lower left, and we're going to click on Project Manager here in the lower right, and we're going to click Add because we want to add a new project, and we need to give this project a name. So I'm just going to put NSA space 123, just a simple name. You can change caps versus lowercase with the buttons here. So there's lowercase, there's caps. You also have other keyboard options in here depending on your preference. So we're going to use NSA 123. I'm going to click OK, and it asks me, do I want to use this as my current project? Yes, I do. So now that's my current project. I need to tell the NSA what type of project this is. Is it a validation project? So validation would be that multi-gig SNR type testing, or it would be maybe a 1 gig SNR test through the side Ethernet port, but we're not going to do that. Network validation would be if we're doing testing for network connectivity, ping and trace route and switch detail, that kind of thing. We could tell it it's a network validator. Now the unit will switch back and forth automatically when you select those. So even if you're within a validator project or a Certalite project, You can switch back and forth between those modes, but you can set up projects specifically for that. The project we're going to set up is going to be Certalite right here. And you do have a coax option, so if you have the coax adapters, you choose that. I'm going to click on Certalite and click Save. So now I see my project in Project Manager. I'm going to hit my back button, and here's my project. I see that I haven't run any tests yet. I'm going to click on Edit Test Profile right here, the green button. And this is going to allow me to go in and select what I want to test. So the first one is our NSA limits. You can see we've got international limits. We've got TIA, Cat 3 through Cat 6A. It's defaulted to Cat 6A channel. I'm just going to leave it there, but you can change that if you need to. There's also parameters for Profinet in here. There's application limits, so if you just want to test it to 1000 base T, for instance, gigabit, to see if the cable will support that. And then in the custom field, if there were custom limits, they would be in there, and that would be something you could reach out to us if you needed to do custom limits, and we could get those imported. And then coax is here, so those would be typically the limits you would use. And the wiring, you can choose 568A, 568B. There's crossover variants in here. I'm going to leave mine at B here in the US. That's mostly what we do. And for the cable, I can select which cable I'm using. Right now, it's a generic Cat 6A, unshielded. If I click on Edit, I can now go to the cable library. So, I can pick a particular brand of cable that I want. Maybe I'm using this XL brand here. So I would click on XL, and then I could see those cables and choose the one I want. I'm going to leave it at, if I choose one I want, I could click Save. But I'm going to leave it at my generic for now. There's also shielded cables, so there's generic shielded. So if you were doing shielded, you could do that as well. When you do select shielded cable and a shielded jack, it enables the shield TDR functionality. So if you are doing shielded cabling and you have a problem with the shield, you get a TDR trace that shows you where along the cable that problem is. So I'm going to leave it with the generic cable. I'm just going to leave the defaults. Same thing with the connector. It's just got a generic Cat 6A. The same process. You'd click on that and then select the one you want. Label scheme, we can create our label scheme. We've got a default A001 to A999. I'm going to click Edit, and I'm going to click Add, and then I'm just going to give this a name, NSA 123, just like our project. Just keep it simple. And we could have a starting and ending sequence, and maybe it's B1 -1 -1 -01. And in this case, this is building 1, rack 1, panel 1, port 1. We're just going to do a simple building, rack, panel, port here. So my ending sequence is still going to be in the same building. I'm not doing different buildings in this case. B1, and maybe we have 4 racks, and maybe we have 6 panels per rack, and each panel is 24 ports. And then I'll minimize that keyboard, so I'm starting at rack 1, panel 1, port 1, and I'm ending at rack 4, panel 6, port 24. I'm just going to click Add and click Yes. I'm going to use it as my label scheme, and then click Save. So now that label scheme is saved in here. Now when I test, it's going to increment alphanumerically through this labeling scheme. And I just use numbers here. You could also use letters. So then you have the last field here is the operator. So it just says default. I'm going to add an operator. I'll just go ahead and put my name in here, or we'll just do my initials, SJC, and click OK. And yes, I want to be the current operator, and save. And now I can go back, and I can see my project is in there. And now if I hit my home button, I go right back to my home screen. Now we're ready to do a Certalite test. Now I'm going to go into cable Certalite. One thing that we would recommend before you do tests, take your remote terminator and you want to connect it into that top Ethernet port. That's that channel port right here. We're just going to connect it into that channel port, and we see we get a live wire map. It's instant. We'll get the same thing when we connect to the cabling over here. We'll see that live wire map. And what I want to do is go into Tools, and I'm going to click on Set Reference, and I'm going to say yes. So basically I'm just making sure I've done a set reference with my remote terminator so that everything is good, everything is zeroed out. Now there is that tone generator. We talked about the tone generator earlier. I'm going to plug a cable in here. We'll demonstrate the tone generator real quick so you can see that. Just going to plug a short cable in here. And I'm going to go in and click on tone generator. I'm going to grab that tempo 200 FP filter probe. We've got tone 1, tone 2. Those are just different speeds of the warble in the tone. I'm going to select tone 2, turn my probe on, and then if I go to my cable here, I'm hearing that tone. It's a slow warble. Now notice there's a buzz from AC voltage. If I hit the button on this probe again, that buzz disappears. But now I can hear that tone much better. So something else you can do when you do tone and probe operations, you will get bleed over. So if we're tracing on a panel like this, you'll hear tone on more than one port. And sometimes your ear can't tell if it's loud enough, if it's one is louder than the other. In order to compensate for that, you adjust this gain or volume knob down a little bit at a time and keep going back and forth in between the suspected ports. And at some point, only one port will make that LED light up, even though you're still hearing tone from both. And that is going to be where your tone is. So just a quick tip on that. So that's the tone generation function. So I'm going to turn my tone generator off. The other things you've got in here are a length test and NVP. So with those, when you've got the remote terminator at the far end, you can do a length test on a cable if you know the NVP, or you can do learn NVP if you know the length of the cable. They're just kind of the opposites of each other. And the auto test is going to include your length as well. And that's why it's important that we choose the proper cable so that we have the correct NVP value in there to give us the most accurate length measurement. So those are the tools. So we've done our set reference. What I'm going to do is I'm just going to take my remote terminator here, and I'm going to plug it into this port right here, port 2. I've got a panel here, and what I've got is some loops of wiring behind the panel, and they're connected to adjacent ports. So now I'm going to plug into the other port right here a wire map, and we do. Now note we get remote ID unknown because we've got a wire map problem. And in this case, we would want to fix that wire map problem, and then we'd know we get a good wire map. We'll see that remote ID. In this case, we've got an open on the blue pair, 5 and 4, and we've got a short on the brown pair. But how do we know where it is? Is it right here at the end of the short cable, or is it down at the other end? If I click in the middle of the wire map, it's going to diagnose the wire map, and it's going to tell me how far away that issue is. And it'll show up here in a second and tell us what that distance is. 3.9 feet. So I'm going to say this isn't a 3-foot cable, but the NVP could be off a little bit here. It's going to be right here because I know I've got more than 4 feet of cable behind this jack. And so it's going to be right at this near end. Now, I'm going to switch ends so we can see if I had connected to the other end of the cable. We'll see a difference in that distance. So you can see that. So I'm just going to click right in that wire map again, and we'll get that diagnostic, and it'll tell us how far away it is from this port. And that will also confirm that I was correct, and we're seeing almost 44 feet. So it is at that other end. Other wire map scenarios you might see. Let me grab I'll grab a couple other adapters here. We'll plug into this port here. And I've got remote number 4. We've got a cross here. So this is B on one end, A on the other. Let's go to the next set of ports here. I'll plug another adapter in. And we got remote number 8 here. This looks like a good wire map. So I'm going to go ahead and run my auto test. I'm going to click on auto test. And this test in the Network Service Assistant takes about 10 seconds to run a test. Our certifier is a 6-second auto test. So if you are doing certification and you're thinking about a certifier, look at that. It is the fastest on the market. And here we see we have a problem with this. Even though the wire map looked good, we've got a problem. So in here we can go into the Details tab and we can scroll down. We could look at our plots just like we would on a certifier and see what's going on. What's my damage here? How bad is it? And I can see I've got quite a bit below that threshold, that limit line. But in the field, we want to know where the problem is. So we failed next, we failed return loss. Let's look at RL locator. We got a big spike of return loss here on the near end. We don't see return loss at the far end. That's because in a single-ended test, you can't really see the return loss on the far end. So if you do have return loss failures, you see one like this, you want to correct it. and then run a test from the other end just to make sure there's not a problem there as well. For crosstalk, we can see both ends. And in this case, I can see I've got a crosstalk problem at the near end, roughly at the end of this cable, but I've also got a big one out at the far end. If I click on that and use my little arrows here to zoom in on it, it's about 85 feet out, and it's a pretty bad one. It's a big spike there. There's also a pretty decent spike right in the midspan of the cable here. So if I go in and I click on that, we're going to see I've got a good spike about halfway through this cable. So the spikes we're seeing here and the spikes all along the cable are caused by different things. The spikes along the cable are because this is a 5E cable. I tested it as 6A, so it's showing more crosstalk than we should have. The other spikes at both ends, especially the far end where we see that really, really big spike, is caused because I intentionally untwisted the pairs. So we can see those type of problems. And this one in the middle was caused by kink, so a cable that's damaged during installation could exhibit that. So those are troubleshooting tools that will help you figure out where the problem is when it does fail. You can save a failed test if you wanted to save it as part of a punch list. So now I'm going to go to my next set of ports here, and we'll run another test and see what we get. So I'm going to go ahead and go back to my testing screen. I've already got my wire map. I'm going to hit auto test, and hopefully this one will be good and I've done my job properly, and we'll be able to see a test with a pass on it. And at the end of the test, we will see our wire map again, and we will see the results. So we get a summary, we see the length, the delay, everything is there. We can click on wire map, we can click on details. Network compliance tells us everything we can run over this cable. So if I click on that, I see that because it's a Cat 6A and it passed, I can run everything up to 10 gig. We can see our length, delay, all the details in here, DC resistance, and we do measure the loop resistance. We also measure, in NSA, we measure the unbalance between the pairs, which is important for power over Ethernet. If you need to do unbalance in pair, you'd want to use a certifier for that. And we just save this. And again, it's going to the next one in our list. If I wanted to save it as something else, I can just click on a Save As, and I can call it whatever I want. It might be just some custom label. So if you run into something that's not part of your label scheme, you can just put FG1, whatever that might be, and that's going to be the label for that one. I just created that FG1, so if I do another one and do a save as, it'll increment to FG2. But my regular list will stay intact, and it will continue to increment through that regular list. So that is the copper test portion of it. I'll quickly show you offloading test results. The quickest way is going to be a USB thumb drive. We plug that into the USB port that we showed you earlier in the video, and when we do that, we'll get a USB menu that will pop up. And we just click copy test results to USB, and here's that project we just did. I'm going to select it and click yes. So that's the same way we'll save all of our results. You can also do a direct transfer to the computer using that USB cable in our Test Data Pro PC software. And you can also connect to the cloud if you've got an Ethernet connection with internet connectivity, or you're using that Etamax adapter and connecting to the internet via Wi-Fi or a hotspot. So next we'll go ahead and jump away from the Certolite test and go over to multi-gig PoE. The first one we'll start with is going to be the PoE test, and it's going to switch modes here. So the first thing I'm going to do is I'm going to go ahead and connect to a PoE source, and what I'll do is I've just got a PoE injector right here, so we can just plug into that, and we'll be able to see that we've got power over Ethernet, but I have to switch ports. I was not in the multi-gig port. That is key. So you want to use the port on the right. That's the one that's labeled 2.5 gig, 5 gig, 10 gig PoE. And here we see, yep, we've got connectivity. So I know that switch or that injector is giving me power. I can see an allocated power, 71.3 watts. I can just click on this PoE load test, and what it's going to do is tell me how much power I can get here. Now, with this really short cable, I better be able to get more than that allocated 71.3. The 71.3 is a theoretical number based on a good working length of cable, up to 100 meters, and it has to be performing as designed in the specs. So we see here I'm getting 74.19, so I'm getting more than that 71 watts. I can even bump this a little bit by hitting the plus button, and it'll bump it up a little bit. Every time you bump it up or down, it'll increase it by 10 watts and give us a reading. The external load test is used with an external load box, not something we really do in the field. More of a lab test, and you can contact us if you want more information on that. So we'll go back to our home screen, and next up we'll do a multi-gig test. So for this multi-gig test, I'm still connected to that same PoE injector, which then in turn goes to a switch, a multi-gig switch. We're going to click on multi-gig. We can modify the settings for this test if we want. If we click on this project button here and we go to edit test profile, we can actually change in this IEEE 802.3. You can select what you want as far as speeds go. I'm going to leave all these checked. If you don't need all these, uncheck the ones you don't need. You can also set your signal to noise ratio limit in here, to whatever you'd like. 0 is the IEEE limit, and if you get to 0, that means your signal and your noise are about the same. I'm just going to leave them all on here, and we're going to run the test, but it will run faster if you don't select the ones that you don't need. So I'm going to click on auto test, and what this is going to do is it's going to run through a connection test at 100 meg and 1 gig to make sure we can connect, and then for the 2.5, 5, and 10 gig, it's going to run not just the connection test, but we're putting traffic on the line, and we're measuring that signal to noise ratio. So we're looking at how much noise there is relative to the signal that we're putting on the line, and at the same time, we're demanding PoE load from our power source, our PSE or our injector in this case. So we're demanding that load, so at the end we'll get a report that will show us everything that we're looking at here. It'll show us the connection speeds, it'll show us the SNR, and it will show us if we did indeed get adequate PoE at the endpoint. And here we see our results, and we see that we passed 10 gig, 5 gig, 2.5 gig, and we can look, if we click the view button and we didn't like one of these, we could look at it by pair. We click on this 100 meg, 1 gig, and we see that it did connect, and we look at PoE, and we see that we do have PoE on here on all 4 pairs. We've got 74.1 watts. We see our PD class, and we can save this. So I'll hit my home screen to go back to the home screen, and next what we're going to do is switch over. I'm going to disconnect from this network, and I'm going to hook up to another switch over here. Just got to move my tester over a little closer to the switch because I've got this short cable, and I'm going to connect to the other switch that I've got over here, and I'm going to go into network test and cloud, and I'm going to click on network test, and I see I am connected. If I wanted to connect to the cloud to upload test results, I can click on cloud right here, and I can click on add account, and I see my information's already in here. I can just click login, and it will go ahead and log me in, and I'm logged into the cloud, and now I can upload my results by just hitting the sync data. So if we go and grab this NSA 123 that we just did, and I tell it to sync data, it's going to go ahead and upload those tests in that project into the cloud, and I can now access that at the tdpcloud.com website, and I can generate a PDF from there if I like, or I can download them into my computer. So we'll close that. So that's the cloud. I will go into network tests here. And in network test, this is where we do our network discovery. We'll start discovering devices. We can see we've got a few devices discovered already. If I click on the icon of the NSA, it's going to gather information about my network. I see my IP address I obtained, my subnet, my default gateway, all this information. And I am using DHCP here. If we're on a network where DHCP for equipment like this is not permitted based on your network security settings, and you need to assign a static IP, you can go into settings, and in here you can turn on that static IP and make your assignments in there and then save that. I'm going to go ahead and click on switch detail right here, and my switch is running LLDP, so I'm going to tell it LLDP. Advanced switch test, I would leave that toggled off. There are some switches out there that you may need to use that for, but for the most part, leaving that unchecked is what you're going to need. That's really more for older, there's some older switches that aren't compatible that need some additional things done behind the scenes. So the LLDP, I'm going to run that. I've got it set for 30 seconds. It shouldn't take 30 seconds. It only took me a couple of seconds to get my results back. And here I see the MAC address of my switch. I know what port I'm in. I see the name of the switch, the details of the switch, the IP address, what VLAN I'm on, and more information about the port capabilities. So I'll go back to my screen here and I see discovered devices. I can click on that. And in here I can see my MAC and IP addresses. If I turn on host name, if any of these host names are advertised, it will show them on my list here. And then whether I've got a list with host names or just IP and MAC addresses, on any of these, I can just click on that device and it's going to pull up whatever information is advertised about that device. And then I can also ping that device as well if I wanted to do so. Once that information comes up, we'll have the ping button will show up. And here we see we've got information about this. It's one hop away. If I hit my ping test, it's going to start a ping test to that device and I can see I'm reaching it. So I'll stop my ping, I'll go back. I'm going to go back again and we're going to go into tools. And in the toolbox, we've got ping like we just did, but here I can ping not just an IP address, I can ping web addresses, I can enter a web address if I want to. And let's say we're troubleshooting for a customer and we're having trouble getting to Google or whatever website. Ping shows us that we've got some kind of problem. We'll do traceroute and do the same address. Go to Google, run traceroute, and now you can see where the slowdown is. It'll show you all of the IP address hops along the way, and you'll know if, say, the first 3 are part of my main network here, and I know I'm responsible for them, or the first 4 are, and that's where the slowdown is, then that's where I need to look. But if it's not on any of those, then I wouldn't need to worry about it because it's beyond my control. Switch details, the same test we just did. VLAN discovery is used if you run it into a trunk port on a switch. You can see the different VLANs and the frame count that is discovered. Traffic generator, typically traffic generator just allows you to send traffic. If you've got another device on the network to monitor traffic coming from this IP address, you can see that it reaches. TCP Connect allows you to make sure that your TCP connection is working okay on a specific port for whatever resources or apps you might be running. And we've connected, we can hit TCP response and it'll show us if we have any delays. So that's the network tools. You can also run an auto test here, and if you click and run that auto test, you can also upload that and save the details. It'll give you the information about the network. It'll give you the information about how many devices it discovered. It will give you the ping results and those kind of things, and the switch detail, all in that test report. So I'm going to hit my home screen, hit my home button here to go back to the home screen here. The base T port is very similar to the multi-gig port that we just used. The base T port is that side Ethernet port, and that lets us run a 1 gig SNR test instead of a multi-gig SNR test. So it's a very similar test. The process is exactly the same. If you want to see tests you've already run, you can hit this data button while you're in that project. It'll show you all the tests on that project. You can click on it and click view and see that individual test just like we did a moment ago. So I'll hit my home button now. So let's go ahead and cover the Wi-Fi aspect of the NSA real quick. So again, we're using this Etamax USB Wi-Fi adapter. I'm going to insert it into the side of my NSA, and then the NSA will recognize the Wi-Fi adapter. And when I go into the network test and cloud, it will show me my Wi-Fi button will be active. So we'll click on our Wi-Fi icon and we'll turn on our Wi-Fi. And it's trying to connect to something that is no longer in range that I was previously connected to. So in just a second, I'll just X out of this, and I'm going to click on another network here. And now I need to go ahead and enter my password for this network, and we'll click OK. and we have connected successfully. Now notice also we see other networks within range. We see the SSIDs, we see the channel these are on, and we see the RSSI, or the relative signal strength, in dBm. If I click on the green click for connection option area, it shows me the IP address I've obtained. I've got my AutoConnect turned on. I've got a Wi-Fi handoff limit. This is useful when we use the signal strength tool. So with it being set at negative 75, if it gets below that, so if it gets to negative 76, negative 77, it's going to disconnect and try and find a stronger connection point. So I'll just save this, and you can set that range anywhere between negative 60 and negative 90, whatever you need. So I'm going to go into my tools here. And in network tests, we have a lot of the same tools that we've already examined in the physical test. We can go in and get network information just like we did before. If I click that, it gives me information about the network I've connected to. There are tools in here very similar to what we have. We do not have switch detail or VLAN discovery. Those are only in a wired network. But the ping, trace route, TCP connect, traffic gen, those are all there. Same thing with the device discovery. It works exactly the same. So what I want to do is I want to go into my tools, and I want to use the signal strength meter. And with this, I can roam around the facility, and I can watch the bars go up and down. I can see my signal level right now is good. If I get into a worse area, it might show poor. And I see the RSSI in dBm right here for my signal strength. So that is the Wi-Fi functionality. Additionally, when you're connected with Wi-Fi, you can also run that auto test when you're in that network test function. I don't know if you noticed that button, but you can run that auto test. But also right here for cloud, we can connect to the cloud just like we did when we were wired into a network connection. So this works in here as well. We can just go in here and tell it to log in, and it will log me in over the cloud. And if I've got a good connection, there we go, logging successful. So same process here. So that is the Wi-Fi functionality. So I've already connected my my fiber test adapter. I've showed you how to insert and remove adapters. It's hot swappable. You just plug it in. I've already got the initial test reference cord connected. I haven't connected the receive end of the cord, that LC, yet, because I want to demonstrate that. But when you connect these, you've got two ends. You've got two different reference cords on the LC setup. You've got one with a Frank Charlie, an FC, and that's a thread-on style connector. The other one is going to be your LC, and that FC goes into the transmit port, which is your light source. The LC is the receive end, and when you do a set reference, a single jumper set reference, you'll just connect that one cord from that transmit port over to the receive port. And I'm going to connect that just in a second here. I've already inspected and cleaned that so that everything's set. Just to show you the adapter itself, so you'll see on the top of the adapter, you've got a transmit port and a receive port, TX and RX. The TX is that FC, that Frank Charlie. The RX is the LC. Now we do have interface kits that you can change these out to SCs or to STs if you need to as well. I've got the default setup here for testing LCs, which has that FC on the transmit port. When we connect, we're going to connect that FC to the transmit port. Now I'm going to show you a zoomed in picture of this connection because it's important to understand in case you're not familiar with the FC. So when you connect that FC to the transmit port, there is a little tab on that test reference cord that needs to align with the slot on the top of that port on the fiber test adapter. So it's important to line that up, because what can happen is if you line that up incorrectly and that doesn't go into that slot, you'll still be able to thread the connector. That's the design of the FC. It'll still thread, but what's going to happen is you're going to have an air gap in there and you won't be able to do a successful set reference. So just wanted to explain that. And the process is we would connect it, you line it up, connect it, and thread it down, and then it just threads right on there. And then the other end is going to get snapped in. It's just an LC. It plugs into that receive port on this end. So I'm going to set this adapter out of the way. So that's the FC to LC, but the other cord that you get with the unit is an FC to FC, and I'm sorry, an LC to LC. So here is your LC to LC. You can see both ends there. They're both LCs. After we perform our set reference, we're going to disconnect from the receive port on this first reference cord, and we're going to connect this second reference cord in here to give us two cords coming out of our unit so that we can test. So the first thing we want to do is go ahead and perform that set reference. So I've already cleaned this, inspected, I've just got it sitting here waiting for me to connect. So I'm going to connect this into my receive port. Just going to go ahead and plug in. And when we plug in, we get an instant wire map, just like we have with the copper. Now, before we do our set reference, one of the things I want to do is walk you through setting up a fiber project real quick. So I'm going to go ahead and hit my home button. We'll go into project. We can leave this where it is. It defaulted as a single mode fiber. We could keep it as the same project if we want to use that same labeling scheme. We're testing different links or whatever, but we'll show you how to do it. We go into project manager. Let's go ahead and add a project, and let's just call it NSA F1 for fiber 1, and click OK. Yes, current project. We're going to go ahead and tell it is single mode fiber, and we're going to click save. And then we're going to hit back. We're going to go in and change this, and we're going to edit. It does default to loopback. You cannot do anything other than loopback with the NSA. Dual-ended single direction, dual-ended bidirectional are only for Test Pro. This shares the same firmware, so you see those options, but you cannot do those tests with NSA. So it is a loopback. We need to choose our standard. Right now, as we can see, we've got the 568-3-D single mode reference grade. If we go in here, and even though that says certification, NSA is not certification, it's still using certification standards. So it's using the certification limits. And right now we see we do have reference grade. I'm going to click on the standard limit, and I'm going to update this to the latest version, which is the E version. 568.3-E. We're going to do single mode inside plant reference grade. I'm going to select that. We see here we get 1 dB per kilometer at both wavelengths. We get a half dB for our end connectors. This additional connectors is only if we have an intermediate cross connect somewhere where we have to account for the patch cords that are connecting two panels there. You would put the number of connectors on that. So if you had, one intermediate cross connect, you're going to have two connectors there, one at each end of the patch cord connecting to two different panels. And you get 0.75 for those. If we had a splice, we'd go ahead and put in the number of splices that we have. And if you're using mechanical splice-on connectors, they count up here as connectors, but you also need to count them as splices here. I'm going to leave this limit as it is. I'm going to click Save. And now, same thing that we have with copper. You can choose the fiber. It's set to generic, but you can go in and there's a library. The selection process is identical. And the same thing with the connector. You've got a few of them in here in the library. Or you can just leave it as the generic, which is what I'm going to do. The label scheme and the operator, same thing. I'm going to click Edit, and remember the label scheme we created before. I want to use that same label scheme. So it's already there. I'm going to use it. And then now I can go to Operators, and because I'm already in there, I can go ahead and select myself, and we're ready to go ahead and do our set reference. So I'm going to hit my Home button. We'll go back into that fiber certification. We'll go to Tools. Couple things to point out here. We've got a VFL built in. I'm going to turn that on, and there's a port right here. I've got a little red cover on it right now, but that is our visual fault locator. It's just a 2.5 millimeter universal, so you can use that for finding breaks. DC set reference, you don't need to worry about that. That really only applies to resistance measurement with a certifier, where you're doing both ends and measuring the copper conductors on a hybrid powered fiber. NSA will measure the voltage on a hybrid powered fiber, so you do have that available for you. Light source and power meter mode allows you to turn NSA into either a light source or a power meter. So if you've got a separate standalone power meter or standalone light source, you can set NSA in that mode. Or if you have two NSAs, you could set one as a light source and one as a power meter if you just wanted to do some quick troubleshooting. And then fiber inspection, again, we've got the visual inspection scope that plugs into the side. You can see more details if you go into our full training. We'll show you all that, but it's always good, whether you're using our scope or somebody else's, make sure you inspect before you connect to anything. And then set reference. You do have to let this warm up for 5 minutes. I believe I've been more than 5 minutes. We got one jumper method selected. I'm already got my cord connected. I'm going to click set reference and I'll click OK. And now we're going to set reference. And when it's done, it gives us a reading. And for single mode, these readings are fine. I'm going to click the check button. And now is when I'm going to add the other cable. Now, typically what you want to do is you want to connect that other cable and then plug them together with a bulkhead and run a test to make sure you don't have too much loss. You want less than 0.2 for single mode, less than 0.1 for multi-mode. I'm just going to go ahead in the interest of time and I'm going to connect to my fiber under test, and I'm going to grab my other LC cord and we're going to make sure that it is clean and ready to go. Get my handy dandy fiber cleaner here. And I'm going to clean one end. And technically I should be inspecting and cleaning. I'm just going to go ahead in here and connect. And so what I've done is I've now taken one end of this first reference cord goes into one port. The end of this other cord I'm connecting goes into the second port. And then at the remote end of where I'm testing, I've got my little loopback adapter that came with my NSA, and I'm going to plug that into the port on the fiber panel. And I should get a wire map, and I do. And again, I'm seeing a loopback wire map. If I was doing a main and remote with a Test Pro, I would see a connection going straight across. This is the NSA, so we're only going to be doing loopback. So we know we've got a connection. Now I can click on Auto Test, and we can see what our fiber looks like. We passed. We see the length of the fiber, just over 100 feet. I've got 153 nanoseconds of delay. I've got margin at 1310 and 1550. If I look at my loss, I can see my loss values at both wavelengths. And then I can see my network limits. So this tells me based on the limit I used, based on the fiber I told that I was using, based on the length and the loss values, what I can run over this fiber. And now I can save this, just like I would any of my other tests. And that is the fiber testing portion of it. And that is the NSA. So this is the end of the quick start video for NSA. Thank you for your time. Please visit our website at www.aem-test.com for more information, or you can email us at customercare@aem-test.com. Thank you.